yeah, Quintal, I like because Anna initially told me that students were having issues in either in the like beginning sessions or at the very end. So what I did was like actually I uninstalled Rust from my system. So in the meanwhile, like if there are no students, like if no more students are joining, so why not I like
DSC, I don't know if he's a mentor or it's a student. Hello?
oh hi, can you please like tell us your name because it's really hard to like call you with that. Hello.
Or maybe if you can talk right in the chat.
Yeah, it's chat also. Sure. Yeah, he said hi.
Good.
No, it was Anna, sorry.
Yeah, it was Anna. Well, no problems.
Okay.
We can continue.
So like, should I install it while sharing the screen or like first I install it and then I just start
I
our
think if
session?
you install sharing your screen is good, so we can see the
Okay,
problems
yeah.
and how things go.
Yeah, so let me like share my screen first. Okay.
Yeah, there is another person, Jet1986.
Jet is a mentor with you
Oh,
in
good.
Portuguese, but he always talks in the chat. He can open the microphone.
Good.
So tell me if my screen is visible to you guys or if it is.
Yeah, it's starting to appear. Yes.
Okay, yeah, sure. Like so like let me so if I'll also brief what I'll be doing if uh, that will be I think that will be better. So like if you don't have Rust installed in your system, you can go to this site and mine operating system is like it's Windows only, so I'll be using this one. If you are a like Mac iOS operating system user or maybe a Linux one, you can use this. So I have already installed this setup file. Let me just proceed with the installation. Uh, Default installation, just press enter. My screen is visible by the way, right? Can anyone confirm? Hello, anyone there? Um, let's wait for it to get installed. Excuse me.
Hey guys, thanks for getting
Okay,
this
so
on.
now,
Just testing the mic.
oh, hi, PFC, it was you, right, who talked right now?
Yeah.
Yeah, okay. Can you please, like, tell us your name if you're okay with it?
Of course, yeah, my name's Pete.
Pete. Oh, hi, Pete.
Shush.
Hi, Pete. Where are you
Hey
from?
guys. I'm in Germany and from Australia.
Oh, very nice.
Oh, okay.
And where in the build you are? In
Very close to the
which?
beginning, let's put it that way.
Okay, very
Oh,
nice.
like you are like a beginner, right? Okay. So you saw like what I did there, right? You have installed Rust it properly. in your
Yeah,
system,
I've
or
got
you
them
like had?
set up.
Okay, okay. So like you install nightly also, like for that formatting part we'll be doing, or because we'll be needing Rust nightly version for that, if I must tell you. Can you confirm that also, please?
Sorry, yeah, I've got nightly installed. I think I've like run through 0, maybe some of 1 or half of 1.
Oh, okay. So okay, I like just let me also install this nightly version also. Then I'll set that for my code directory. First up install nightly. So, Pete, is there like any particular section you want me to start from? Like from, if you have any doubt, or I think I should just start from the beginning only. No worries in that.
Yeah, so I don't know if I'm the only student that's present. For me, it would be helpful just running from the beginning.
Yeah,
But
sure. Like
I mean,
let's begin from the beginning only. Let's start from the beginning, and we'll like do it till the end of the third session, like I say. And we'll see if we have time, we can like code more also. Depends on my speed. I don't know if I'll be able to like do it. Okay, so now nightly is also installed. So and we have this nightly version also. Okay, now let me uh, wait for that. Let's start from here because in this one I had nothing. And let's do dot. We don't need these now. And in the terminal, let's run that command cargo init, which is going to initialize a tree for us. Okay, have it here and let's run do cargo run once. Yeah, okay, so we are done with this much part. And also like I have prepared, I have kept it this Rust format, Rust fmt file, separate file, like simply paste it. Uh, okay, we have the formatting file also now. Let's do, let's override for, let's first do the step show. And I have the active tool chain of stable. So like, so let's switch to nightly version. Rust up, step override. Click. Right. Okay, now I guess we have the nightly version Rust. Let's check it with Rust C hyphen. Yeah, okay. And also check this cargo plus nightly FMT. Okay. Yeah, okay. I think with this we are basically done with our section 0, I guess. Let's check it. Yep. We need to like use a first FMT and then we'll use cargo. Oh, okay, cargo FMT. Okay, let's. Sorry. System Let me close the. Uh, just a minute, guys. My hello.
Hello. We are following. Following.
Yeah. Sorry. Like it's my system's got lagging a little bit, so I should like close the extra tabs over here. Sorry for that.
No problem.
Okay, so let's begin with the section 1 and let's create a balances.rs file in our root directory. Oh, not in our root directory, in our src folder. Balances.rs. Let's include this in our main. And Pete, I'm assuming like you have been through these steps, right? Like you already did these.
Yep. Yeah.
Okay, so like we have included this and let's see what else. Okay, well, we'll initialize our struct with a of uh, pallet. And yep, I think that's pretty much it. I should just get rid of all this and let's do cargo. I prefer to use cargo R. I can use cargo run, it's the same thing. It's just thing of priority only, nothing else. Sorry, I forgot to save it. My bad. Let's move. Okay, so let's add state to our palette now using the collection of storage BTreeMap. I guess you must be familiar with that. Standard collection and BTreeMap. And inside our palette, we'll have the I guess the balances field. Yep, which will store our balance, basically store, and we'll do a lot of stuff with it. Yeah, BTreeMap. It will be a map from the accounts to the balance only, which will represent with string for now, and balance will use for balance will use you unsigned 128-bit integer data type. Let me add a comment here also. Uh, Better I should add a documentation, a storage map, uh, mapping accounts string to their balances will be 120. Okay, now we'll be implementing some functions over our structure, our object palette, which we'll use later on. So this is the syntax for that. Until palette. And in this, let's create a new instance of our palette struct. Create a new instance of our palette. of our balances palette. Let's just call it that. So we'll use the new function and it will return a basically just our object only. Uh, so yep, balances and for and the initial like for the initial stage will be there will be no balance. Okay, so balance will be 0. Let's do a cargo run. And I'm getting an error using standard collections BTreeMap. Oh, okay. Folded it wrong. Also not sorry. We won't be using this. We'll be using this. A new instance of a BTreeMap. Okay. So for now we can like ignore the warnings. And I guess this is the first section. Yep, we have implemented this after this one. Let's move ahead. Let me see. Pete is here. One more. Is Glauber also a like Anna? Is he also a mentor on his student?
No, Glauber, he's a student.
Okay, so hi Glauber. So I don't know uh, if you like followed up till now. So like you can
I did
tell us
some of the steps
first
before,
up to
and
which
yeah, I did
sir.
some steps before, so you can just continue, and I will be watching here. If I have any questions, I will talk.
Oh, okay, yeah, sure. Uh, so let's add functions, basic functions, and like it starts interacting with our balances palette. So I'm going to write some more functions over here. First one, let's do will be using the balances function, like get balance and set balance. Yep. Let's first do the set balance. Set balance of an account. Let's call it and sub function. We call it set balance. Uh, let's pass in the our instance into the function address of mutable cell and root with which will be the address of string. And it's not going to return anything for now. It will just take the sorry. We'll use amount also, which will be setting 120. So basically we'll just use self dot balances set balance basically insert key will be who and value will be our amount. If I save it, it will throw me an error because what it will say, expected string, found address of string. And if we try to use, try to dereference it, it's still going to show us error. Cannot move out of asterisk who, which is behind a shared reference. Consider cloning the value. Oh, sorry. Wait. Consider cloning the value if the performance cost is acceptable. And for now, I think it's acceptable, so we'll just use dot clone over here. I think now it should work. Let's do cargo build to check everything's fine. Yep. Now let's create a function to get the balance of a user. Get the balance of a user. And if balance is not there, we'll just return 0 of a user. Function. In a tutorial, they call it balance only, but I keep it like more verbose, so I use get balance instead. Address of cell because we won't be moving, we won't be just be reading value from it, and will be returning us a balance which will be U128. So then dot balances. We use the get API. Pass in our key. Let's save it and see what errors we'll be getting. Mismatch types expected U128 found option address of 128. So this we are getting because dot get is returning us dot get API returns us a option value data type. So we need to use it. We cannot blindly do unwrap over here. So we use unwrap or, and in a default value will give 0 as if the dot get API returns us none, will return 0 there. We don't want to return none basically. So let me save it, and I'm sure we'll still get some error. Expected U128 found address of okay. So let's just dereference it using an asterisk, and I don't think we should get error now. Okay. Let's do cargo build also one more time and see there are any errors. Okay, so yep. Let's see. Cover. Okay. I think we are done with this section also. Now we'll use this function and write tests for it. Okay, so let's go under that and use this macro over here, configure test, create a module which we'll call tests. And in this way, uh, if you have studied Rust from the Rust book and you know how to write tests, every test is basically just a function, and we need to use this hash test, this macro over that function so that the compiler can know you are writing a test. That it will be a test whatever function is written under it or not. Any system I'll write init balances So here we'll create an instance of our palette, balances palette, uh, like this. We want it to be mutable because like we'll be setting balances of some user. So we need this mute over here. And like you can use super over here for accessing the palette, but what I prefer is like you should do this create syntax, create, and then because it's like it's more verbal. Under create you will find balances module, and inside balances you will have your palette. And to like we have created this, implemented this new function on our palette struct, so we'll use that. And yep, we got this. Let's create our users. Alice first to Alice will be a just a user will be a string, type string. And what checks do we need to perform? Assert that the balance of Alice starts at 0. Okay, so let's do that. Assert equal, and we'll use the balances that we created, balances, the dot notation, and we'll do the get balance. Now pass user over here, address of Alice, and it will be 0. Let's check this. So we have a shortcut for writing, instead of writing a whole cargo test, you can just write cargo T over here and press enter. Let's see. Okay. So balance of Alice is 0 in the beginning. Let's move ahead. What else do we have to check? Set the balance of Alice to 100. Okay. So for that we'll be like using the our instance directly balances dot. We have created this set balance function who will be sorry, Alice, address of Alice. We'll use a reference over here because we have defined set balance in which we are using the address of string. That's why I'm using address here and here also. And amount will be 100. Now let's assert balance of Alice now. Balances dot get balance. And address of Alice, it will be 100. Let's do cargo T. Okay. So I think the last one we have to check for Bob. Assert that the balance of Bob has not changed and is 0. Okay, let's create Bob first. Let Bob equals to Bob dot to string and sorry, so equal. Let me just copy because I'm lazy. Bob. So let's do cargo T1 final time for this section. And yep. So with that, I think the balances palette will be. Oh no, we'll have the transfer function also. Main functionality of our balances palette. So let's begin with that. Transfer.
Ethan, just a question. Did the test pass from the other one that you just did?
Yeah, the test pass you can like see over here. Is this visible?
What,
My terminal?
this is only one of them. What about the other assertion? Alice and the Bob.
Oh no, like
Not
yeah,
here.
Globber is it right? Yeah, Globber. Globber. This works. This works as what this terminal is showing right now is this if this test is passing or not. We have like created init function init initialize balances. You can say it that the compiler knows
Oh,
that this is a test. Okay, so uh, the number of times you write this hash macro test, uh, that number of times you will be like that number of tests you will be getting in the terminal. So if like this failed, like if I write, let me, I think it will panic and we do not have any. Let's do address of Alice 1 because we know that balance of Alice should be 0 in the beginning, right? And if I'm writing 1 over here, that means I know I'm failing this test. I am like that I want this test to fail. So I'll write 1 over here and like let's do cargo T and see what happens. Oh, it's still oh I didn't save it, sorry. See, it failed now. And you can see the Rust is like so verbose, it tells you at what line number. You can see in here also src balances.rs at 33. At 33 line number, left should be 0. This is the one that's written before this comma. It should it should result into 0, but we are getting 1. So it failed, and wherever the first time it will fail now, you will get that error in the oh sorry. You will get that error in the terminal. Okay.
okay, I got it. Thanks.
Okay. So let me just correct it again and run cargo T now. All these checks are like getting checked. So you will not see test 4 times over. If we have written assert equal 3 times, you won't be getting 3 tests over here in terminal. Okay. I think that's clear. So I should start implementing this transfer function. Transfer extrinsic. Let's create that. Transfer an amount from one account to another. This function will also check that the caller of the function caller will have at least amount balance to transfer. Okay, so let's write it a function transfer and let's pass in a mutable reference. Well, caller will be a string and 2 will also be a string. Let me, where is this? Amount will be 128 and this will be result, the return type of this extrinsic will be a result. Whether the transfer is successful or we get some error. Okay. Pete, like you have done this much, right? If you can just confirm.
Not till now, so I'm just watching you from here on. But
Oh, so like if you are having any errors, you can like ask, right? First we'll get the balances of the account.
Cool.
Caller. Get the balances, let me comment over here. Get the balances of both the accounts. I should write get the current balances, both the accounts. So we'll get let caller balance equals to self dot get balance we have created, and we'll pass in address of caller. Okay, let just ignore this one error for a while, and we have let to balance self dot balance address of 2. Okay, so what else? Like use safe math to calculate the new balances of both the users. I'll explain what safe math refers here. Let's give it a comment of calculate the new balances of both the accounts using safe math. Let new caller balance equals to caller balance. What we'll do here is caller balance dot we'll do checked sub. Now what this checked sub do is like it returns I should say like it returns an option, and if we use okay, we use unwrap or maybe okay. No, not unwrap, or we'll use okay or brace, so that we can if the like if there is any maybe underflow or whatever like arithmetic underflows or overflows, we'll return some error message over here. So let's write over invalid and not invalid, insufficient funds. Huh. Oh, not RM over here, we'll do amount. So do you guys want me to explain this what we are doing over here? If let me add this also. Now Pete, Glover, anyone?
I think it's
So
okay.
Like you guys know now what we are doing with over here. How we extracted this U128 new caller balance using these two. Or like should I explain it? I think I should go for this.
maybe you can just explain checked sub.
Yeah, so check sub, what it will do is my voice is echoing. So check sub basically it returns an option result type. What if like if there is everything like what it will be doing, it will be subtracting the amount from caller balance. This And if some like if everything goes okay, it will return that okay variant. And if we get an error, we'll will show that error through this okay or. Like also this question mark plays a big role over here. If I don't put that question mark over here, you see the result, the type of this new caller balance is result U128 or address of str. So to extract that OK variant from this result, no, to extract that OK variant from this result, we use this question mark. It's basically it takes out that OK variant part. And if we get error, we'll just simply print return this insufficient funds error message. I I hope it if that's clear.
And now, before this check, we need to understand it as well, right? Because if it's negative amount, then it will pay, but it's not correct.
Sorry, can you please repeat? Robert, I couldn't get you.
The amount needs to be always, right? The transfer amount.
Yeah, amount will be like positive only. No, no, not this check. This checksum is not checking whether the amount will be positive or negative. Uh, well, well, if we are using a unsigned 128 integer, no, this amount is not going to be negative. It can be zero, but not surely it won't be negative because you are using an unsigned 128-bit integer over here. Okay, so this checks up what it is doing is it's subtracting this amount from this caller balance. We extracted this balance from the uh, pallet struct, right? The balance is BTreeMap. We extracted caller balance from that, and we are subtracting this amount using this checksum. Now checksum is what checksum do is it returns it returns a result type for you. So result is basically an enum which has two variants. One is okay and second one is error. So if everything is okay, we'll extract the remaining balance after subtracting it from caller balance. We'll extract it using this question mark over here. If I remove this question mark right now, you can see the type inferred over here is result type U128 and address of str. Like it's basically just saying a string or nothing else. If the return type of this checked sub comes out to be an error variant, we'll just simply return this error message instead. That like if we say Alice is transferring to Bob, so Alice didn't have enough funds so that she can transfer this amount. Okay, are you getting it? What I'm saying? To extract this okay variant like this 128, the remaining balance, to extract it, you have to use this question mark over here. What it will do is it works like it extracts the okay variant from that result we are getting. Is this clear now? Like, should I move forward?
Yep, that's good.
Okay. So now let's also calculate the new balance of the two where we are sending, and we'll just do what we'll do is we'll add this checked add and we'll write amount. Again, we'll use the okay or. And what now what can happen is when you are subtracting from caller balance, like you can get an error of insufficient fund. Like for example, if Alice don't even have amount balance, you'll get this error, right? But in case of adding the balance, what if the tool, let's say Bob, already has like max balance, and by max I am saying I mean the maximum value of this U128 unsigned bit integer. If he already has max balance, you cannot add more balance to it, right? So we arithmetically like check this error using this checked add, and we'll say, let's say balance overflow, and again use this question mark to extract the OK variant if it's added successfully to Bob's balance per se. Is this like, I think it's also clear to you guys? There should be no errors. No, sorry, no error. What I'm saying. There should be no confusion with this, right? Let me know if there is. Because now we just need to insert the new balances of both the users. So is there any doubt with this? Like self dot balances dot, you just need to do insert, and key will be caller and value will be new caller balance. What we are basically doing is we are overwriting the storage right now. Self dot balances dot insert to, and then value will be new to balance. And lastly, because we specified a return type to be either a error message string or an OK variant, so we need to use this OK here. I think now there should be no error, and I can do cargo run. Let's do cargo run once. And yep. So let's write test for this. Okay. Test will make it more clear what we actually did over here. Function transfer balance. Let's create a mutable instance of our struct. Sorry, balances pallet new. Let's create our users Alice. Let me just copy it. We just need these two only. And let's do now one thing, that Alice cannot transfer funds she does not have. Okay. So like I'm not setting balance for Alice right now, and let's try to perform a transfer. Balances dot transfer. Let's call Alice. We'll be using clone over here. Otherwise we'll be getting errors. Clone over here also. Let's try to do balance transfer of 100. Let's do 50 token. Oh, sorry. Wow. And like we'll be getting error in this case, and the error will be nothing but this one only, because we haven't set any balance for Alice, and Alice's balance is 0 right now. So it will result in an error of insufficient funds. Let's save it and let's do cargo test. Let's run this test and see the it's passed. Now let's set balance for Alice. Balances dot set balance. Here will pass address of Alice and let's give her 100 tokens. Now if we try to perform this, instead of an error, we'll get an OK variant. We'll get an OK. And let's run this test. Yeah. Now let's check Bob's balance. It should also be 50 by now. Balances dot get balance will pass address of Bob over here and it should be 50. Let's do for Alice also. Let's first do for Alice and then for Bob. Let's save it. Run cargo T. Yeah. Now, what I want you to like, I want to show you this balance overflow also. This condition when like if Bob had already had the max balance, then what we'll get it. So to set balance max for Bob, what we'll do is balances dot set balance Bob and amount will be it will like it's a way to use max for U128 and that is this. Like now the Bob will have maximum value of what this U128 can offer. And if we try to like let me copy this. Like even if we try to transfer one token now, what we'll get is balance over no. I've written it this way only, right? Let me just check. Yeah, balance overflow. Let's do cargo T now. And yep, it passed. So this is what checked add and checked sub is doing for us. I didn't save it. Sorry. Let's try now. I'm pretty sure the result will be same only. Yeah. Okay, so I think with this our first section is done. So like did you guys have any doubt in this section? Any like you want me to address? Otherwise we'll just start writing. We'll jump into the second section.
Yeah, no, all good.
Vishesh, do you want to
Yeah,
continue or you prefer to schedule another meet?
I think I can do one more section, and I don't
Oh, okay,
like have problem with that. If the guys want that.
let's do it.
Yeah, we
If,
want.
Yeah, for sure.
Okay, let's
yeah,
go.
Thank
so
you.
okay, let's create our system palette now, and in our src folder only, src directory will create a system.rs file and let's include it in our mod system. Okay, so basically system palette, what system palette consists of, it consists of the meta, it is a meta palette which stores all the metadata needed for your blockchain to function. For example, the current block number or the nonce of users of your blockchain. So let's create this palette. Let's first import that BTreeMap. First we'll be using that only. Standard collections BTreeMap, and let's give it a comment that this is our system palette, and so system palette, it consists the metadata about our project. So we'll define it with pub struct palette only, and what it will have is it will have the fields of, like, it will consist of block number, which will be U32 for now, and second it will have a nonce, which will be a B-tree map of from account to, I'll write the comment over here also, account to a U32. That will be our nonce field. So like nonce is basically a number that is used once. So what we will be using it here for is, like, if Alice is executing some transaction, like we did just did, like transfer only. So whenever a transaction will be done by some user, we will increment their nonce by 1, so that we can keep track of the how many transactions a user has made. Okay, so that is why that's basically the use of nonce. Type to represent, not a type, field represent the current block number, a map from counts to their nodes. Okay, let's like implement the functions for our system palette. And first one is always will be the, like, creating a new instance of our system palette. A function new self block number. Also, like, I forgot to use that cargo FMT. Will be using that now. Okay, block number will be 0 in the beginning, and nonce will be basically a new object of a BTreeMap. Okay, let's save it and run cargo run first, and then we'll also do cargo plus nightly FMT and see basically code is formatted here, I guess. Here also. Yep. Okay, I guess this is the, yeah, this is the first lesson. Let's move on to the next lesson. Making your system function. Okay, like, now let's implement these functions for our system palette. get the current block number. Function block number. It will have a address of self, and what it will return is just a U32, and we'll just simply return self dot block number. Okay. Next we have like we need to increment the block numbers also as we move forward with the chain. So we need this function too that will be increments the block number by 1. Up function inc, let's call it increment block number, and we'll be passing us mutable reference this time. It won't be returning anything, it will be just incrementing the number. Self dot block number plus equal to 1. Yep. So now we need functions for uh, nonce also, like we'll increment the nonce. Increment the nonce of an account. This helps us. Yeah. I did not just copy you. I am a bit lazy. And what we'll do is let's first get the nonce. Let nonce equals to self dot nonce dot get. We'll increment the nonce of the user, and we are passing user as this parameter who. So let's pass who, and you can see like it's option, it's type referencing as option of address of U32. So what we'll do is we'll unwrap or, and if the user, like if user didn't existed, we will simply use 0 as default. And also it's address of U32 we are getting, so like dereference it. Okay, so now nonce, we get the nonce of the user who from our nonce storage, nonce BTreeMap storage. Let's create a let new nonce equals to nonce plus 1, and last step we'll do the storage self will insert this new nonce. Sorry, self dot nonce dot insert for our user who. We have error mismatch type expected string found address left string, so we'll use clone over here. Okay, and let's do cargo build. Yeah, I guess we need to create test also for this. So let's write test for our system pallet. Configure mod test Let's create a module for test. Test macro, define this as a init system. We call it init system, and let's create a mutable reference for our system palette. Again, you can use super over here, but I use this. I prefer this create system and then palette. Okay. Let's create our user. Let alice equals to alice dot toString. Let Bob equals to Bob dot toString. And yep, increment the current block number. Let's increment it system. We have created a function increment block number, and now we'll assert if a block number has incremented or not. System dot block number, and it should return 1. Okay, and now let's check let's just first run cargo T over here. It's really hard to get. Yeah. So initially Alice's nonce should be like, it should not exist, it should be returned, it should be none. Let's check for Alice's nonce. System nonce dot get address of Alice, and it should be none. Let's see if this works or not. Yep. Let's increment nonce for Alice. System dot increment nonce, and we'll pass in. Let me check. Will be passed. Yeah, address of Alice. Smash type expected this, found integer. Oh, sorry. We do not need to assert anything. We'll just increment it. Now we'll check for her. Let's copy this. And now it should be some address of 1. I'm right. I'm using this sum and addresses over here because if I just directly write 1 over here, this dot get method is returning me an option values. Either there will be some value or there will be none value. So if I just write 1 over here, right? Let's check that also. It will be giving me an error. It says expected enum option address of U32 and found type integer. So like if I wrap it in sum, now it will be saying expected still, yeah, expected enum option of address in U32, found enum option of integer. So we'll just add address over here. Now it should not return any error. Let's do cargo T. And my system is a little slow. Sorry guys for that. One lastly, we check for Bob's also because that is basically the same. save it and run cargo T. Finally for this. Yeah. So system palette, like we have implemented our system palette. Is there any doubt you guys have in this? Or else I should like move on to the next session, next lesson. Because now we'll be creating our, we'll be tampering with our main.rs since we haven't touched it till now. It's just says fn main over here. Oh, it's just printing hello world for now. So like if you guys have any doubt, now's the time to ask it.
That's okay. Thank you.
Oh, okay. So should I move on, right? Uh, like this is our main runtime. What it will do is it will accumulate all the logic that our state machine has to offer. I don't know if you guys are getting annoyed with this commenting and all, but I I really love to write a comment over everything that needs an explanation basically. Struct runtime. And this runtime it will just it fields will be like our pallets only. It will have the system palette, and how we'll get the system palette, we'll use the create syntax over here, system palette, and we have balances. So we'll get that by balances palette. Yep. Let's also run cargo plus lightly fmt. Maybe. Yeah, let's create an instance of our runtime also using implementing runtime. Create a new instance of our runtime. Do not need this function to be public. We'll just use fn new, and it should be returning an object of our runtime. Return this system. Look at that from system palette and a new instance of system palette. And basically, we'll do the same for balances also. Just a new instance of our balances palette. And let's do cargo run now. Yep. For now, you can just ignore the warnings. And let's execute our block using our runtime. Yeah. Now let's create a block and do some actual, using our pallets, do some actual transfers while handling errors and all. Okay, so in our main function, I'll create a mutable instance of our runtime. Mutable, let's make it lowercase. And we can create it with this, like this, runtime new. Okay, Now, oh sorry, let's create our users. Let Alice equals to Alice not to string. Let Bob equals to Bob dot to string. And let's also have user Charlie this time. Let Charlie equals to Charlie dot to string. And let me check what we only need to do. Start emulating a block, increment the block number in system. Also, like for the initial state, like we call it the genesis state of our blockchain, let's assign Alice with some balance. So for that, let me also add a comment, set balance for Alice in the genesis state. Runtime dot balances dot set balance, and we'll pass in Alice, address of Alice. Let's assign her 100 tokens. Okay. And now let's start emulating a block. Block. And first, let's increment the block number. Increment block number. Runtime dot. Now, like we can access these pallets using our dot notation. Runtime dot system, and then we can use these functions that we have created. Like now, you'll see how all this is getting connected, and use this function increment block number. Okay, and let's check if the block number is incremented. Assert equal runtime dot system dot block number. It should be equal to 1. Next, we have to do, like, I think this is the most important step. Let's create the first transaction. Transaction in which send 30 tokens to Bob. Alice sends Alice sends 30 tokens to Bob, and let's create this while handling all the errors. And if we get any error, we'll print it to the console. So execute a transfer from Alice to Bob. The transfer could return an error. We should use map error to print the error if there is one. We should capture the result of the transfer in an unused variable like underscore result. Let me just write some code and I'll explain what we'll be doing. So underscore result runtime dot how are we going to transfer, use balances, and then the transfer function. Caller will be Alice, and I'll use clone over here because then we'll need Alice again also for transferring to Charlie. And I can use Bob. I don't need to add clone over here, and let's do 30 tokens. For better readability, let's do it like this. Now this part, like this much part, runtime.balances.transfer. This transfer function, this transfer extrinsic, oh, not extrinsic, this transfer function will, it has a return type of a result. No, let me show you again. Either we'll get an OK if the transfer is successful, or we'll get an error message. So, like if the transfer is successful, we'll just wrap up the result in this variable so that we do not get any warnings and all. But if it returns in, if it does not, the transfer does not go successfully, does not happen successfully, we'll just map the error, whatever it is, into this closure. And now this, I don't know if you guys are familiar with the closure or not. If you're not, please let me know. Like I can explain what I'm doing over here. What this will do is, yep. And with this, like you have handled error also and executed the transfer. If Alice has balance, that is. So please let me know if you guys are familiar with closure or not. Like this, do I need to explain this part?
Yeah, if you could walk through it, that would be great. Thanks.
Yeah. So basically, what closure here is doing, this map error will basically take out that error part. Like I told you, result variant has two parts. One is okay and the other one is error. So what map error will do is it will map that error message into this closure, this E we have written over here. And uh, what this closure do is it like let me like explain this in this way. Basically, this error message will get in this E, and what we are doing here is we're printing that error message over here. You can use println. You can use println also. Println is basically use println only for error and progress messages. Use println instead of for the primary output of your program. So now, right now, like we need to explicitly print the error. We're using println over here. If that's clear to you, let me know.
Yep.
Is there any other, Pete? It's clear, no? Right?
Thanks.
Yeah, so now let's create the second transaction also, in which Alice only she'll be like transferring 20 tokens to Charlie. Transaction. I'm not writing comment this time. Let's directly let's copy this. Because we'll be doing just the same thing only. Now we do not need clone. Always remember this, like whenever you do not need clone, you should not use it because it's expensive operation, you can say. And here we'll write Charlie. Transfer of 20 tokens. Okay, now let's print let me add a comment over here. Print the final state of our runtime. To do that, we'll simply do println, and under this I will be using this syntax, and I'll explain why we are using this syntax inside these parentheses or these curly braces. And here we'll give our object runtime. See, we are getting an error. If I remove it now, if still will we get an error? Yeah, because structs objects like you cannot print them directly to the console. I don't know if you guys know about it already or not. So we have to like print them using the debug format, and this is basically the debug format only. If you use this hash, if you don't use this hash, you will like get the let me show you the output. First, let's implement derive debug for this. So we use this debug macro over our struct derive debug. Now still we are getting these two errors. it says system palette doesn't implement debug, and balances palette also it doesn't implement debug. So what we are going to do is like we go over to the our modules and also add this uh, debug macro for our both of our palettes. Hash derive debug. Now I think the errors will be gone. Field nonce is never read. Why is it saying that? Hello. I think we missed one thing while emulating the block. While doing the transactions, yeah, I forgot one thing. Increment the nonce of Alice. We forgot this step. Like every time a transaction happens, we have to like first increment the user's nonce. So let's do that. Runtime dot system dot increment nonce, and we'll increment that for Alice. And before the second transaction also, let's do the same. Let's copy this only. I think now we won't be getting any, not even any warnings also. Let's do a cargo build first and then I'll do cargo run. Yeah, no errors now. Let's do cargo run and see. This is our final state of our balances, or not balances, of our runtime. And you can see like it's all of it's coming in in one line only. And to like pretty print it, we'll use this hash over here. Let me clear the screen and do cargo run once more. See, so let's check our final state of our runtime. We have the system palette over here, we have the balances palette over here. Block number is 1. As you can see, as we incremented the block number uh, before executing the transactions. Nonce of Alice is 2 because you know we did 2 transactions. Alice did 2 transactions basically, and balances of all of the users as updated successfully. So I guess with this we have completed this section. I think the last lesson is derived debug only, and I have showed you guys. Yeah, it's saying that only add hash derived debug on your pallets. Okay, so with this section 2 is basically like so it's complete. Yeah, thank you guys. I think we should wrap it over here. Don't want to bore you guys with that much. Anna?
Thank you, Bishi.
Yeah, I also like if you guys have any error, yeah, so you can like
Yes, thank you
I think
very
it,
much.
I think everything is clear over here, right? Now, how everything got connected into our main runtime from the both of the pallets, like how we implemented the functions, transfer function. I don't think there should be any error. If there are, you can like ask if any
Uh,
syntax or there.
I could record, so I will share with another students, and
Yeah,
uh,
sure, Anna.
and we go on in another time. But I want to thank
Yeah,
you very much for this live coding.
yeah. No, it's not big deal. Uh, thanks